This video discusses the basics of trig identities. Okay, so what on earth is an identity? Well, an identity consists of two expressions, A and B, that are equated, so that the value of A is exactly the same as the value of B for all possible values of a specific variable within a certain range. Wow, what a lot of stuff that is. Let's look at a basic identity. A minus b squared, everybody knows that one, is a squared plus 2ab plus b squared. This will be true for all values of a and b. You can make a 2, b 9, a 100, b 500. This will always stay true for all values. Okay, another one you know is that 2x minus 4 is equal to 8x minus 6x minus 6 plus 2. The left-hand side and the right-hand side are exactly the same. So this is true for all real values of x. Okay, so here we have an identity which is true for all values except x may not be 0, because then we get division by 0, which is undefined. Okay, so what is an identity? It's two expressions that are equal and are true for all values of x, and sometimes for one or two of them not valid. Okay, so the basic grade 10 identity we did is tan theta equals sin theta plus cos theta. This is an identity that's true for all values of theta except when theta is 90 plus all 90's multiples. Okay, this is the way of writing the multiples of 90. Because if you put in cos 90 in theta's place, you'll get a 0. If you put in 90 plus 180, which is 270, cos 270 is also 0. If you say 90 plus 2 times 180, you put that in theta's place, it will also get a 0. So you're not allowed to put in any multiple of 90 there in the denominator, because then it will be undefined. Then we get the square identity, the famous sine square plus cos square is 1. This is true for all possible values of theta. Okay, so what are you going to do with these two identities? Well, first you must be able to prove them. Where do they come from? Then you have to use them to simplify expressions, and then you will use them to prove other identities with. Let's quickly look at the proof of the quotient identity. Okay, how do you prove it? You draw a nice triangle in the first quadrant with an x, y, and r. On the left-hand side, you start with that left-hand side. On the right-hand side, you keep the tan theta. Tan, in terms of x and y, is opposite over adjacent. It's x over y. Sine, in terms of y and r, are opposite over hypotenuse, divided by cos, which is adjacent over hypotenuse, or x over r. We just work with the x, the y, and the r. If you divide, it's the same as multiplying with the reciprocal. And if you simplify the left-hand side, you get y over x, which is equal to the right-hand side. Therefore, this identity is valid, except for the stuff, the angles that make the denominator 0. Okay, so the square identity has got two variations. If you take the sine square over to the other side, then you get cos square equals 1 minus sine square. If you take the cos square over to the other side, you get sine square is 1 minus cos square. How do you prove it? Exactly the same Pythagoras method as the previous one. Okay, working with trig identities are really easy if you just follow the algebraic rules. Okay, so I just want to show a few tricks that you can do with trig identities. Okay, the first trick is that tan square will be equal to sine square over cos square. If you know where it comes from, you can look at the algebra there. The next trick is, if sine square plus cos square is 1, you can't just take the squares and get sine plus cos is 1. That's not true. You can watch that example there if you're not sure. Then if you have sine square x minus 1 and you want to swap the terms, it's fine. Just remember to place the minus in front. And then here we've used one of our identities. 1 minus sine square is equal to cos square. Okay, the products, if you have a bracket with trig identities and another trig identity and you multiply them, first ones give you sine square, the inner ones give you minus cos sine, outer ones plus cos sine, which they cancel, and then the last ones give you cos square. It works just like difference of squares there. A minus b, a plus b is a square minus b square. Okay, if you want to do the distributive property, that's the algebra. You can also do it with sines and sine x minus 2. You just multiply those two terms as well as those two terms and you get the answer. Okay, how do you do a bracket square? A square minus 2ab plus b square. So if you have a sine x minus a cos x square, you take the first one, square it. First term times second term times 2, last term square. Okay, so they in this case, a is sine x and b is cos x. Let's look at some factoring. Okay, some factors. Sorry, that must be a C. Okay, if you look at difference of squares, this expression sine square x minus cos square x can become a difference of squares. Sine x minus cos x, sine x plus cos x. If you take out a common factor, like you did in algebra, you can also do it with sine square x minus 2 sine square x. You take out a common factor of sine x. And if you look at the trinomial, which you're well known with, acquainted with, you can do this with this difficult trinomial. So instead of an a square, we have a sine square. Instead of a b square, we have a cos square. And we just factorize it exactly similar. Okay, so this is a very important one, the trinomial. We use it a lot. Okay, so have a look. This sine square x minus 2 sine x cos x plus cos square x becomes sine x minus cos x times sine x minus cos x. It's two brackets with two negatives. Okay, so let's finally look at 3 little examples where we used trig identities to simplify other identities. If you say any identity with a tan in, always substitute it with sin over cos. Just watch out, this is a fraction and the cos x is not a fraction, so put him over 1, cancel your cos x and you get sin x. Okay, the middle one. What is 1 minus cos square x? It's sine square x. What's 1 minus sine square x? It's cos square x. And what do you know about sine square alpha divided by cos square alpha? It gives you tan square alpha. Look at this one. It looks very difficult, but if you see this, it looks very familiar. We just need to swap the terms, and then put a negative in front. What is 1 minus sine square x? It's cos x, it's cos square x. And now we have a tan x over a cos x times a cos square x. We put this cos square x over 1, and then one of the cos's cancel. And then we get this. And how do we get from here to the final line? Well, we make the tan sin over cos. The cos's cancel, and you get negative sin x. Wow, that was a lot of new information. You must go through this video again slowly on your own time.